Hi guys, welcome back to our third day on Unit 8, Lesson 21. I am on page 407 in your textbook. Please join me. Please grab your calculator and fill in these pages as I am filling them in too. Don't just sit and watch. You are going to get so much more out of it if you write things down. Kind of the process of writing triggers things into your brain and helps you remember. We're going to have a quiz on all of this on Thursday, so I'd really like you to be prepared for it, and the best way to prepare is to be practicing these problems with me. All right, so we're going to do number 24 first, kind of an odd figure. We're going to do the perimeter first, so we're going to go around the outside. Remember that the perimeter, let's pick this color, the perimeter is just all around the outside. So you do not need those inside numbers. All right, I am going to write this down. So I'm going to start at the bottom here. My first number is 12. And then this side over here is 5. And this side right here is also 5. These two are like a mirror of each other. So you've got 5 and 5. I'm just going to write that down as 10 for this whole side over here. Really, it's two sides, I know. But this side over here is going to be the same as this dotted line here, which is the same as this. It's going to be 12 again. And then the opposite side of this rectangle is 5. The opposite side of this rectangle is 5. So you've got another 10. Okay, add those all up. Remember, you can group them. 12 and 12, you know, is 24, 34, 44. 44 centimeters. Notice how there's a space between my numbers, and I just put cm. All right, I'm going to erase before we do the area. And there's a couple of different ways that you can look at this. So when I first looked at this the first time, I saw triangles over here, and then I didn't know what this, I saw a different shape. I saw a trapezoid. Excuse me. But really what you have here is a parallelogram and another parallelogram. Remember, the formula for parallelogram is base times height. Okay, I'm going to erase all my sketches here so you can go back and see those. The base and the height are where you have that right angle. So right here is the base and the height. The base is 12, the height is 4. So it's 12 times 4, and that's going to be 48. But that's just this piece right here. You've got another twin piece up here, which is also 48. So you could do 48 times 2, or you could do 48 plus 48, and you get 96. Boom. Now, over here, I think that you have all the numbers that you need to find the perimeter. So I would like to pause for a moment and you figure out the perimeter. Maybe write your numbers on the line, maybe write them on a piece of scratch paper or out in the margin over here. But I'm going to take a moment here and I want you to figure out the perimeter. All right, I hope that you came up with 26 centimeters. Remember, you could add those sides up in any order. As long as you add each side, you're set. Hopefully you saw 5, 5, 5, 5. That's 20. Plus 3 is 26. All right, now I would like for you to try to find the area of this figure. Now, it really is the shape of a trapezoid, but you don't know how to figure out the area of the trapezoid, so you're going to have to make some cuts and figure out what the area is. Go ahead now and figure out the area of that figure. All right, so let's do this middle piece right here first. You've got 5 times 4, and that's 20. Kind of looks like a square, but it's really a rectangle. So that piece is 20, and then you have 2 twin triangles on each side. They both have a 3 for the base, and the height is the 4, not the 5. 3 times 4 is 12, divided by 2 is 6. The area of each triangle is 6. So 2 of those would be 12. So you have 20 plus 12. That gives you 32 centimeters squared. If you're typing it in, square centimeters. You write it like that, okay? Usually you say it's square centimeters or centimeters squared, usually square centimeters though. All right, let's take a look at number 26. I don't know how to say this name. Vadim needs to know the area of this pentagon. Kind of looks like home plate. So he calls his friend Serena. Serena says she can figure out the area if Vadim will just make 3 measurements. Which 3 measurements does he make? Now, over here, this is line AF. This is line FE, DE, BD, BEA or AB, and BC. So just look at that for a moment and figure out what measurements he needs. Okay, well first he's got to divide it, right? So we'll divide it here. To find the area of that rectangle, he needs a base and a height. So he could either say FE or AD, because that would be the same, right? And AF. So AF could be right here, or he could have said DE. Okay, so those 2 measurements would give you the area of the rectangle. And then up here, the triangle is base times height. Well, AD is going to be the same as FE, right? But you need to know this other one right here, BC. So once you know those 3, you are all set and you could figure it out. All right, this is kind of a piece of information that you really don't have to know as a 5th grader, but it's kind of nice to know. So there will be a question like this on your quiz, so I'd like for you to practice with it. Now, this is a pentagon. You remember a pentagon has 5 sides, so 1, 2, 3, 4, 5. And it's a regular pentagon. Regular means all the sides and all the angles are the same. So they found the center of this pentagon, and they kind of drew a line from the center out to the sides, these are called vertices, vertex. So from the center out to each angle or each vertex, each point on the sides. And they want to know how many triangles are there. Well, 1, 2, 3, 4, 5. There are 5 triangles inside that pentagon. That's kind of interesting, isn't it? There's 5 sides and there are 5 triangles inside. It's not a coincidence. Now, I don't have my ruler to measure the base and the height, but let's take a look at this triangle and let's pretend for a moment that this is 3 for the base out here. And then it's 2 high. This line from the height, from this tip down to the right angle is 2. And we can call it whatever. Let's say it's 2 meters. Doesn't matter the unit. What's the area of the triangle? Well, area of the triangle is base times height divided by 2. 3 times 2 is 6. Divided by 2 is 3. So the area of that triangle is 3 square meters. Or you could write it meters squared like that. What's the area of the pentagon? Ooh. We'll have to figure out all these other triangles, right? And add them all up. Well, here's the cool thing. Remember, it's a regular pentagon. So all those sides are all going to be the same. And then this height is going to be the same as well. So all those are going to be 3 and 2. So really, once we found the area of this rectangle, we know the area of all of these. So if this one is 3, this one's going to be 3, 3, 3, 3. 5 sides, 5 triangles, 5 times 3, 15 square meters. Now we've got a hexagon. In your textbook, page 408, I want you to see how many triangles you can form in that hexagon. All right, so watch what I do. I'm drawing from the center point out to one of the vertices. And if you said there are 6 triangles, you were correct. Now I'm going to give you some measurements for this. It looks like it's taller this way than it is this way, isn't it? Maybe that's an optical illusion, but I'm going to say that this is 5, and I'm going to say that this is 4. I would like for you first to find the area of one of the triangles. Excuse me. And then I would like for you to find the area of the whole figure. All right, base and height, 5 and 4. Half of that's going to be 10. So one of them, one triangle is going to be 10. Oh, and you can make up your own unit, inches squared or square inches. And you have 6 of them. So the area is going to be 60 inches squared or square inches. One more problem for today. Oh, sorry about that. All right, I want you to find the area of this figure. All right, this was tricky because they gave you some numbers that you didn't need. Hopefully you saw that this was a rectangle. Oh, excuse me. Sorry about that. Hopefully you saw that this was a rectangle and this is a triangle. The rectangle dimensions are 10 and 16. Length times width, 160. The triangle was kind of goofy because once you cut off the rectangle, you had to figure out this measurement right here. The whole thing's 22, but you cut this off and the triangle is 12 because 10 plus 12 is 22. The height right here is 16. It's the other side of this rectangle. So you had to do 12 times 16 divided by 2. And really what you get there is 96. You did not need this 20 inches at all. Now, once you do that, you know that you add those 2 pieces together and you have 266 square inches. That was a lot of work for that problem. All right, try your homework for today. I hope you do well, and we're going to have a quiz on this tomorrow. So do your best. Good luck.